In this lesson, we're going to look at the last algebraic concept in solving linear equations. Once we cover equations with the variable on both sides of the equal sign, you will have all the tools you need to solve any linear equation at all. The only thing we can do after that is just make them messier with different kinds of numbers and more of the same thing. So what we're looking at here is when you have a variable on both sides. So for example, if you have the equation x plus 4 on the left and then you have 2x minus 6 on the right. So now we have this issue where we have x's on both sides of the equal sign. So it might be helpful to think of this with our little balance, okay? And this has 1x and then we'll say 4 little plus signs. And this side has 2 x's and 6 little minus signs. And what we want to do is collect the x's on one side. So that's pretty much what we do when we have the variables on both sides. We need to get them all onto one side. So there's options for doing this, but I'm going to use this illustration to kind of give you the feel for it. I have on the left side 1x and on the right side 2 x's. So what I'm going to do is I'm just going to get rid of this x here. I'm going to subtract it, so to speak. Well, now my equation is no longer balanced because I took something off of the left side that I did not take off of the right side. And so I have to do the same thing to the right side. And now my equation is balanced. So algebraically, this would look like 4 equals x minus 6. And now we have the variable collected on one side. So I want you to notice what I did there. What I did there was I subtracted the variable from both sides. Now you actually have the option of adding or subtracting when it comes to consolidating the variable. It's just easier to show in the balance scale illustration if we're taking x's away. So there's two main ways that people will approach this. Some people like to collect the variables on the left. Okay? And that just means that they will get all of their variables on the left-hand side of the equal sign. That's one way, and a lot of people prefer that. Other people will collect to avoid negative variables or negative coefficients in front of the variables, okay? We'll just say negative variables for shorthand, but what we mean there is the negative coefficients. And so the way we did it this way, this is still a positive 1x right there, and we avoided the negatives. I tend to prefer this second way. I like to avoid negative numbers if I can, but you can do it either way. So this was like the picture illustration. On the next slide, I'm going to do out this problem. It's the same problem. And we'll look at it algebraically, and we'll do it both ways just so you can see that both ways work, and it's really just a matter of preference. What a lot of times we can catch, well, I'll mention that in a little bit, but what we did in this step here is we took away, I used my little eraser tool on this app, and we took away an x. Well, the algebraic for take away is subtraction. And so what we did there was we subtracted an x from both sides. Now, this is different from combining like terms. Combining like terms is when your variables are on the same side of the equal sign and you want to consolidate them so that you don't have multiple terms with variables in them. This is actually a collection of the variables on one side. So here we have x minus x, which is 0, leaving us with a 4. 2 x's take away 1x, or 2x minus x is 1x. And then we have the minus 6, and now we undo subtraction with addition. And so we will add 6 to both sides, and we get 10 is equal to x. And most people don't have any trouble like understanding that 10 equals x is an equivalent equation to x equals 10. Now the other way to do it is to try to get the x's on the left side. So on the right side I have positive 2x. So I'm going to take away the positive 2x. I have to consolidate it. So we need that to end being a 0. And then I have to do the same thing. You are hearing my cat. He really wanted to come to this lesson and now he's not paying attention. I don't know what his deal is. All right, so right here we have 1x minus 2x. Well, 1 minus 2, or 1 plus negative 2, is negative 1. Bring down the plus 4. Now, this is a common little mistake here. That 6 is negative. This is where it is sometimes useful to kick into gear, like the definition of subtraction is adding the opposite. So you might opt to write that as plus negative 6 right in there. Instead of minus 6, and that serves as a little bit of a visual reminder that that is a negative 6. So the negative did not disappear or go away. Now we need to get the 4 out of here. Well, I'm adding 4, so I can undo adding with subtracting. 4 minus 4 is 0. Negative 6 minus 4, remember that's negative 6 plus negative 4. So it's negative 6 and then negative 4 more. So it's negative 10. And then we divide by negative 1 to flip that sign. Negative 1 divided by negative 1 is positive 1, or just an x. And then over here, a negative divided by a negative is a positive. And notice that both of those work to get you the value of x is equal to 10. Which way you prefer is entirely up to you. All right, so pretty much the rest of this lesson is going to be going through about 5 more examples, just so you can see all the different ways this can look when you're solving equations. So here's our second example. 7x plus 19 equals negative 2x plus 55. So we've got 7x's on the left, we have negative 2x's on the right. So you want to think, like, what will make that cancel out? What do I add to or take away that will get that negative 2x to cancel out? And hopefully you think to yourself, well, if I add 2x, negative 2x plus 2x is 0, because you're dealing with those opposites. And it's why it's so important several lessons ago, when you really understand the idea of opposites, because then it comes so much more naturally when you're integrating it into that equation. So whatever we do to one side, we must do to the other. And we have 7x's plus 2x's. So that is, what is that? That is 9x's. Bring down the plus 19. We already established that this here was 0, and so we'll bring down the 55. Notice that nice top-down structure. The equal sign never disappears. We can see what's happening in every step. Now we need to get rid of that plus 19. So that's adding 19. The way we would undo that is by subtracting. Bring down the 9x. 19 minus 19 is 0. You always want to remember why something cancels out. And 55 minus 19 is 36. This is multiplication. We undo multiplication with division. 9 divided by 9 is 1. Again, always know why stuff cancels. This cancels out because they add up to 0. This cancels out because they divide to 1. Don't lose sight of it. It grounds the reasoning. And we end up with x is equal to 4. Remember that you can always check your answers, because several lessons ago we established what the solution to an equation was. The solution to equation is the value of the variable that when you plug it in is going to give you something true. So here we have 7 times 4 is 28. Here we have negative 8 plus 55. And this is, what is this? 40, that's a... 47 equals 47, so that is true. And that little factoid can help you on multiple choice tests. If you get stuck, I mean, that's true for any equation, not just linear equations, any equation. So that's the definition. Now, we talked about this in an earlier lesson, where this, like, plus 2x, or minus 19, or divide by 9. Generally, that's considered part of the thought process, or, like, the operations, like you're showing all the operations. But we don't have to show that. And in fact, a lot of higher level math classes, they don't want you to show it. And so I would look at this one, 80 minus 6y equals 4y. And I know that to consolidate the variables, I can add 6y to both sides. But I don't actually show it. I just do it. On the left, if I add 6y, that's going to equal 0. And then 4y plus 6y gives me 10y, and I don't have to show it. This is multiplication. I know I'm going to undo multiplication with division, so I'm going to divide both sides by 10. 10 divided by 10 is going to give me 1, and 80 divided by 10 gives me 8. And so this is what's called the process only, and it is totally okay for you to show just those steps. You don't have to show all this other work. Now, if it helps you to show it, then go ahead and show it. It's not mathematically wrong. If it helps you, do it, because the goal is to get the problems right. All right, so let's just look at some other examples. So this one integrates almost everything that we've done so far. Okay, so we want to start by simplifying each side. We've got a lot of stuff happening in this problem. We got some distribution. We're going to have some like terms in here. We're going to start by simplifying. So we're not even going to worry about like what the deal is with the left and the right. Over here on the left, I have a 4 there that I can distribute. 4 times 1 is 4, and 4 times x is 4x. I'm going to bring down the plus 3x. I'm not doing anything with that. Over here on the right, I can distribute the negative 2 through the parentheses. Negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. And you can write either minus 2 or plus negative 2. Now on my left, okay, I have negative 4x plus 3x. Now, notice that I circled the subtraction. That's because subtraction is the same as adding a negative. That 4x is negative. When I go to add those, negative 4x plus 3x gives me negative 1x. And then I'm not doing anything on the right. Notice we work top down. If you're not doing something with a term, you just bring it down. This 4 is just hanging out. Okay, now that I've simplified each side, now I can work at consolidating those variables. So this is when you start that process of doing the same thing to both sides. I like to keep my variables positive. So I know if I add 2x to both sides, I will end up with a positive variable. Bring down that 4. We're still not doing anything. Negative 1x plus 2x gives me x. And then don't forget that 2 is negative. The negative has to come down with it. And then I will get the x alone by subtracting 4. 4 minus 4 is 0. Leaves me with x. Negative 2 plus negative 4, or negative 2 minus 4, is negative 6. And hopefully if you followed these videos from the beginning, you're developing a way of thinking through the signed numbers that works for you, and that if I do something and you're like, well, I would have done this as a plus negative, that you can make that change on your own. All right, this one, we have 1/4 12x plus 16 equals 10 minus 3 times x minus 2. And so we have a little cringe fest because we have a fraction, and then we just buckle down and we do it. So let's go ahead and distribute. So I'll do a little bit of scratch work over here to the right. 1/4 times 12. Well, that's 1/4 times 12 over 1, which gives me 12 over 4, which is 12 divided by 4, which is 3. So this ends up being 3x. 1/4 times 16 is 16 over 4, which is 4. Here, common mistake. This is a negative 3, and this is where my algebra teacher, where he made us write everything as a plus negative, helped there, because it just was that little reminder that you're not distributing a 3, you're distributing a negative 3. And so we're going to take that negative 3 and distribute it. That's maybe one of the most common mistakes that I see in all of math, all levels that I've taught, is not distributing that negative. It's really, really common. So I encourage you, change it over to a plus negative if it helps you. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Now we have a little bit of simplification. On the right side, I have 10 plus 6. So I'm going to bring down that left side. 10 plus 6 is 16. and then I just bring down the 3x. No subtraction, nothing like that. Like we're not doing opposite operations at this point. We are just combining the like terms. Now I want to get all of my x's consolidated onto one side. So if I add 3x to both sides, I will end up on the left with 6x, bring down that 4, bring down the 16, and now negative 3x plus 3x is 0, and now we're back to a much simpler kind of equation. Let's use gray. Subtract 4, so we get 6x, 4 minus 4 is 0, 16 minus 4 is 12, divide both sides by 6, 6 over 6 is 1, 12 divided by 6 is 2. So don't let those fractions freak you out. Like have your little moment where you're like, fraction, that's lousy. And then just buckle down and do it. All right, last one is, I don't know why I did that. I just opened my color palette when I didn't mean to. All right, 7 times 2 minus x equals 5x. So let's go ahead and distribute. And remember the little lines there, okay, I don't normally draw little lines if I'm doing an answer key for something. I do that when I'm teaching because it tends to help students track through, like your eyes kind of track through the process, but you do not have to write them. They are not part of the work that you show. 7 times 2 is 14. 7 times negative 1x, okay? If that helps you, like this is a 1, negative 1x. So you could place negative x, okay? So 7 times negative 1x is negative 7x. I like to keep my variables positive, okay? But you know what, for the sake of just showing you something, because some of my students, they'll automatically try to get the variables on the left, and then they'll see a situation like this, and it'll kind of throw them for a loop. So let's just say I want to go get them on the left, okay? So I'm going to subtract the 5x. So on the right, I have 14, negative 7x minus 5x. That's negative 7 plus negative 5, which is going to give you negative 12. This is what throws them because of the way that it's structured. 5x minus 5x is 0. And for whatever reason, people don't want to put a 0 there, and the equal sign disappears, or the equal sign migrates to a different location, which can't happen. Like 5x minus 5x is 0. Now I want to get the x by itself, so I guess we subtract 14. Remember that negative right here is with the 12x. 0 minus 14 is negative 14. And we've introduced a lot of extra negatives into this problem that I kind of wish weren't here, but I wanted to show the thing with the 0. Because it's just one of those sticky places. 14 over 12, that can be simplified. They are both even numbers, so they can both divide by 2, and we get 7 over 6, and then half of my students are going to freak out because you're not supposed to get fractions as answers, but you can because they're numbers. So if you do get a fraction as an answer and it does make you uncomfortable, just kind of check over your work. If you can't find a mistake, it probably the answer is a fraction. So as with the last set, I'm going to put some problems up, but I'm not going to talk through the solutions, just to trying to keep the length of the video like under that 25-minute threshold for these videos. So I'm going to go ahead and put the problems up on the next slide. All right, here they are. 4x plus 27 equals 3x. 5r, that's an r, plus 6 equals negative 14r minus 13. 6 times 3 minus x equals 3x. Negative 2 times x minus 5 equals x. Negative 4 times 3 minus n equals 11 times 4n minus 3. 1/2 times 8n minus 2 equals 16 minus 30n. 9 times b minus 4 equals 5 times 3b minus 2. And negative 4 plus y times 10. So this one down here is the distribution is coming in from the right. It's unconventional, but I think it's important for you to see it. Equals 2y. So pause the video, work these out on a separate piece of paper, and then unpause the video to check out the solutions. Okay, in all honesty, when I was doing these out, I had so many fractions as answers. And I pulled the problems from a problem bank, but I had so many fractions in the answers that I had to question my own work. So hopefully I didn't do anything silly that is going to cause a lot of comments on this video. And yeah, people are going to get all upset. But first one, the answer I got was x equals negative 27. For the second one, r equals -1. And of course, pause it on either of these slides. If you have something like negative 27 equals x, that's totally okay. All right. Like that's not a mistake. You did everything right. If you ended up at a different answer, that is potentially a mistake and you want to go back. And I actually did do the whole, like all the steps. And again, that was not because it's required, but because I think it's easier if somebody is getting a different answer to be able to follow along and find exactly where that mistake is. All right, for number 3, I got x is equal to 2. And this was the first one that ended up as a fraction, 10/3. So I did double check this, like negative 2x and then a negative times a negative is a positive. Then I added the 2x to both sides. So x plus 2x is 3x equals a 10. And like I don't see anything wrong with it. So there you go. Again, pause on this slide if you need to review the work. Number 5, I think this was the slide where I was like, am I, like maybe I've worked too long today or something. But for number 5, I got 21/40, which doesn't even simplify. The only factors of 21 are 7 times 3. And like those are not factors of 40. So just, you know, quickly I multiplied these, unless I copied it wrong. I thought I checked everything, but negative 4 times 3 is negative 12. A negative times a negative gives you a positive. 4 times 11 is 44, and then 11 times 3 is 33, and that would be negative. I subtracted the 4n from both sides. This is 0. 44 minus 4 is 40. Then I added 33 to both sides. Negative 12 plus 33 is positive 21. And then divided by 40. So that's where I got. And then this happened. So, but this one is better because at least it came out to a decent fraction, like a nice fraction, the 1/2. So we have n is equal to 1/2. When you distribute the 1/2, half of 8 is 4 and half of 2 is 1, which is another way of thinking about it. Pause on this slide if you need to. And then the last two, like another fraction. I don't know. Maybe I just like picked winning problems, or maybe these are all wrong. I don't know. Like just like you guys, I start looking at it like, this is not how math books are written. But all right. So we have 9b and then minus the 36, 15b and then minus the 10. I subtracted 9b from both sides because I like to keep it positive. That, of course, is 0. 5, 15 minus 9 is 6, so I have 6b. Then I added 10 to both sides, ended up with negative 26. Negative 26 divided by 6. I didn't do the simplification in a separate step because I was running out of space. But these are both even, and so they both divide by 2. Half of 26 is 13, and half of 6 is 3. So I got negative 13/3. It's a little hard to see the 3 there. And then for the last one, ended up with y equals 5. Remember that there is flexibility in how you structure the problem. So you might have opted to like subtract the 10y from both sides, and that's totally okay. That goes back to that very first problem that I did where you can move things around in a different way or in a different order. If you got to the right answer 99% of the time, that means that you did it correctly. The other 1% in these weird situations where you make 2 mistakes and they happen to cancel each other out. Does happen, but that's an 8 right there. That's terrible. Okay, so that's really everything that anyone can teach you algebraically about solving linear equations. This is it. The only thing we can do is mess with the numbers and give you fractions and decimals and stuff. And that will be the topic of the next lesson. I will say that what I am not doing in this video series is word problems, mostly because they're very difficult to transfer the platform and to put the word problem into into this particular platform. I might add some videos later, but the idea is that if you have the solid algebra skills in place, then when you're in your algebra class, you can focus on making that transition into like the word descriptions of it. So just in case anybody was wondering about that. So I will see you in the next video on decimals.